Hi, I'm Natalia from the IntelliCAD Technology Consortium, and this is a review of the VLISP command. The VLISP command was first introduced in IntelliCAD 14.0 and allows you to run Visual Studio Code with the IntelliCAD LISP debugger extension. In this video, I will demonstrate how to create, debug, and test Lisp code. I will also use ChatGPT to assist me. Please note that AI-generated Lisp can be imperfect or unconventional. So, our goal is to use it as a solid foundation, which we will refine with IntelliCAD LISP debugger. Let's get started. How often during your work have you thought, I wish there were an extra command for this task I keep repeating? For example, I needed a tool to detect gaps in my line work. I asked ChatGPT to help me write a Lisp routine, and here is the result. Consider this as a first draft. The AI helps me quickly generate runnable code, which I then review for naming, logic, and edge cases to ensure the routine adheres to IntelliCAD best practices. Now, I'm creating a new file in the Visual Studio Code editor, inserting the Lisp routine, and saving it with the LSP extension. After that, all predefined functions are highlighted, the help information appears when hovering the mouse over them, and the context menu offers many options. Let's run the code. I click the Run and Debug button, and the script uploads to IntelliCAD. It now appears in the autocomplete list. And I can run the Find Gaps command. As a result, all gaps in my line work are circled, but I noticed two issues. Each gap gets several circles, and the endpoints of the lines with no potential intersections are also circled. The result of this script is incorrect, and I want these circles to be more visible. Let's use the debugger functionality to investigate our code and identify where we can fix these issues. This step is essential. Even when AI helps us get close, the debugger workflow and inspection tools are crucial for transforming a rough draft into production-ready Lisp. When I'm looking at the code, I can see that it consists of several different blocks: variable definitions, endpoint collection, endpoint comparison, gap marking, and program termination. I set a breakpoint at the end of each block by clicking to the left side of the line number. By the way, the list of all my breakpoints is displayed at the breakpoints section of the debug console panel. Running the code again, it stops at the first breakpoint. At the variables section, you can see the list of all variables, both local and global, that are defined and used in this code. At the watch section, you can add expressions or variables to track. For example, I want to find out how many objects were selected during the Find Gaps command execution. So I'm typing this expression and see that there are 9 objects in my selection. Now I will navigate through the code using the debugging buttons from the debug toolbar and observe how the variables change at each step. First, I'm pressing the Step Into button to enter the first method, moving further using the same option. And on the list of local variables, you can see that we've got a first entity. And on the next step, its properties. Now you can see that the 2 endpoints have been detected and added to the list of points. When we get to the Compare Points block, we have a full list of points. Let's count them using this expression. And we have 18 points in the list. It looks like the standalone endpoint bug is located at the third block, where the detected endpoints are compared. Let's review its logic. If points P1 and P2 are not completely equal, and the distance between them is less than the tolerance, the method writes these points as a close match. And later, if points are not a close match, it will be circled. That's the error. The expression that should be here is this. The root cause of the second issue, double circling of the detected gap, is also located in this method. There is no check if a gap was found for the same area more than once. Let's add it. This is a good example of AI-generated code that functions but requires human oversight. The last thing I wanted to change in this script was the color of the circles. And to fix that, I will ask ChatGPT's help again. While AI is excellent for making small tweaks, we always ensure correctness by verifying and testing in the debugger. All done. Now, to load and execute a script without restarting the debugger section, I will use the load Lisp command. Let's rerun the find gaps command and check the results. Gaps are circled only once, in contrasting colors, and the standalone endpoint issue is gone. Isn't it exciting that with a little help from ChatGPT and the new IntelliCAD tool, you can create, test, and run any script you need? Remember, AI is your accelerator, not your replacement. Start with ChatGPT, use VLISP, and rely on your engineering judgment to guide you. I've included a link to the final version of the LSP file created in this video in the description, so you can try it out too. I hope you found this video helpful. Please leave your comments, and thank you for watching.